High in the mountains, the air is thin. It is hard to breathe up here. The wind is cold. The ground is frozen. No trees, no shelter, just rock and ice. Scientists knew someone had lived here, but for decades, they had almost no bones to prove it. No skull, no complete skeleton. So how did scientists knew this ancient human ever existed? That question would lead to one of the strangest discoveries in human history.
In a cave in Siberia, scientists found a tiny finger bone. It looked like almost nothing, too small to tell them anything on its own. But in 2010, scientists tried something new. They pulled DNA from inside that bone. They expected it to match a human population they already knew. It didn't. Not us, not Neanderthals. Something else. An ancient human population science had never identified before. Scientists named them the Denisovans, but one bone raised more questions than it answered. If this species was real, where else had they lived?
The trail had started in a Siberian cave, but the next clue was waiting thousands of miles away on the roof of the world. High on the Tibetan plateau, in a place called Baishia Karst Cave. The cave sits about 3,280 meters above sea level. That's over 10,000 feet high, higher than most places where people live. Inside, a jawbone had been sitting for over 160,000 years. There was a problem. This time, scientists couldn't get any DNA out of it. The bone was too old, too damaged, so how could they ever know who it belonged to?
Here is where the story takes a strange turn. DNA was gone, but something else had survived. Tiny fragments of ancient proteins. And those fragments carried a hidden identity. Scientists read them like a fingerprint. The answer became clear. This jawbone belonged to a Denisovan too. For the first time, science had identified an ancient human without a single strand of surviving DNA in the bone itself. It revealed something extraordinary. Denisovans hadn't just lived in a cold cave in Siberia. They had reached one of the harshest, highest, most oxygen-starved places on Earth, and they hadn't just visited.
Up this high, every breath fights you. The air holds much less oxygen than your lungs are used to. Climb a few steps, your chest already burns. Now imagine that in the Ice Age. Cold winters, short, uncertain relief, snow that could bury the ground for months. So here is the real question. How did anyone survive here? Not for a season, but for generations.
To answer that, scientists went back to the cave floor, not to guess, to look. They studied more than 2,000 animal bones buried there over thousands of years. Evidence 1, hunting. Wild sheep and goats appeared again and again. Evidence 2, tools. Cut marks showed that someone had processed these animals with stone tools. Evidence 3, animal skins. The evidence suggests they may have used animal skins for warmth, but archaeology still leaves us with questions. We still don't have clear evidence of exactly how they managed fire at this altitude. We still don't know how they protected their children through the coldest months. Some answers may still be buried in that cave floor. Others may be gone forever. Imagine a Denisovan standing at the mouth of the cave, tired. The wind cuts straight through. In this reconstruction, they wear simple animal hides, pulled tight against the cold. Somewhere behind them, a small fire flickers. Their family is waiting there, depending on them. For one more day, they kept everyone alive. Tonight, they survive. Tomorrow, they will have to do it again. At some point, Denisovans disappear from the record at this cave. We don't know exactly when. We don't know exactly why. The trail simply goes quiet. But before it does, one more discovery changes everything we thought we knew. In that same Siberian cave where this story began, scientists once found the bone of a young girl. Her mother was a Neanderthal. Her father was a Denisovan. Two different ancient human species, one daughter. For a long time, scientists had pictured these ancient humans as separate branches, living apart, rarely crossing paths. This one bone rewrote that picture. They met, They lived close enough, long enough, to become family. But the Denisovan story didn't end with ancient bones. Part of their genetic legacy survived inside later human populations. Some modern Tibetan populations carry a Denisovan-derived variant in the EPAS1 gene, which is associated with adaptation to life at high altitude. Not every Tibetan or Sherpa carries the exact same variant, but this genetic legacy shows up far more often here than almost anywhere else on Earth.
Think about what that actually means. Somewhere, right now, a climber is standing at high altitude, lungs working harder than most humans ever will. A small part of what lets their body cope with that thin air may trace back to a species that left no skeleton, no face, no name. A Denisovan never stood on a summit for glory. They weren't trying to conquer anything. They were only trying to survive one more freezing night. And without ever knowing it, their genetic legacy may have helped later humans adapt to one of the harshest environments on Earth.
We still don't have their full skeletons, ancient proteins, and fragments of DNA. Evidence shows Denisovans across more than 100,000 years, oldest, most breathless places on Earth. They weren't necessarily the strongest for longer than we can easily imagine. But their genetic legacy may still hold home. And this is just one of many. We explore the mysteries of ancient humans, lost civilizations. If you enjoy documentaries, because there are many waiting to be uncovered. Thanks for watching.